Hi guys. I know I haven't asked you guys, but I'm going to ask you guys to keep track of your notes and to buy a journal for this class. So this is pre-cal. We're going to take quite a bit of notes. It's good as reference. It's good for you to study. Um, it's good for the homeworks. Okay, guys. I always like to use the very first page as a table of contents, and as you guys know, we're going to build this journal. So right now, we're going to cover the first topic, which is chapter 4.1 in our books, and it's inverse functions. So this is just like the table of contents, okay? Um and just add 4.1, 4.2, the two titles, and then hopefully every week we could just add on to this table of contents, okay? All right. So before we get into the inverse functions, I want us to do like a little warm up. So, um, what I want you guys to do is I want you guys to try to remember what happens when you're going from this equation, whoops, to this equation. So, what I want you guys to do is if you have a calculator, put this in your y equals and then this one in your y2. So y1 and y2, and see the differences. You can do the same for number 2, right? You're going to put this in y1. This will go y1, y1. We're going to do this several different times, right? And I want you to see the changes. Now, if you do not have a graphing calculator like handy dandy with you, you can go to the internet and go to desmos.com. Okay. So desmos.com is an online graphing calculator. And as you can see, it says right here, graphing calculator. So when you hit graphing calculator, it takes you to the graph. So this one right here would be like your y1. So I'm going to type in y equals, I'm sorry, was it y equals? I think it was so. Log of x. And we have our first equation. Now, our second equation, I don't remember it. It was 5 log parentheses x minus 2. So now we have y equals 5 log parentheses x minus 2. And I want you to tell me what happened. So from the red to the blue, what's happening? Well, we could automatically know that from the red to the blue, there's some type of shift this way. There's some type of shift. In fact, let's look at this point. What point is this? This point is 1, 0. And then if we was to shift this point, where would it shift? To 3, 0. So from this point to this point, how much does it shift? It shifts 2 to the right. Now, it also changes the curvature, right? So we have this one, which is kind of, I guess you could say, a slow growing rate. And then this one would be a faster growing rate. So when we come back over here, we could say, we could say it shifted to the right. So this is key. And we could say the rate increased because we notice that the curvature is going at a much higher rate. Okay. So what I want you guys to do is I want you to try to look at these next couple of them. Okay. Put them in your Desmos, put them in your graphing calculator, and then fill in what you guys get. Okay. Some of them might be 2 or 3 different things. Some of them might be 2 different things. Some of them might be 1. Right. So just Tell me what you notice. Okay, do you notice the rate increasing? Do you notice that it reflected? Do you notice if it shifted to the right, if it shifted to the left? Do you notice that it shifted up or down? Tell me what you notice, and please write it right here. Write it right here, and I will give you some time. So go ahead and pause the video, work on these 3 problems, and then we can go from there. Okay, so I'm not going to do all the warm up problems, but I'll do one more. Okay, so this last one. f of x equals e to the x, and then we're going to transform it to this. So I go back to my Desmos, and I have my function e to the x, which is the red one. So my key point right here is this one right here, this 1. And then I have e to the x minus 2 plus 4. So I notice something's happening. So this point has to be something special right here, right? So we have this point that's special, and we have this point that's special. Maybe if we could zoom out a little bit, let's see if we could see another special point, right? So maybe this is a special point, 2, 5. Okay, so what do we notice? So if we was just to look from here to here, what do we notice? We notice a 1, 2, 3. I don't, maybe a little bit more. If we look at this, what do we notice? So you should see that from the red to the blue, from the red to the blue, we should see a shift of 4 units up. So right here, we could say shifted 4 units up. And I believe, this is a plus 2. And I think I put a minus 2. So let's see what happens then. Plus 2. So what happens? No, it shifted to the left. And guess how many units it shifted to the left? 2 units. Okay, so shifted 2 units left. Okay. Now, the rates pretty much look the same, right? It still looks like it's still increasing. If we kind of grab this, they kind of look like they're just shifted. So it looks like it's just moved up and to the left, okay? So the rates don't look like it's changed. But now, let's get into these questions. How does one check if a function is an actual function? So you might have remembered something from Algebra 1, possibly Algebra 2, how to check for a function. There's some type of special test, right? So it is called the vertical line test. And this is going to be key because we're going to add something to this, right? So when we have a function such as, say we have a parabola, right? The vertical line test states that if I draw a vertical line anywhere on this function, it should only cross that function 1 time. And if it crosses 1 time, then it's a function. Conversely, if I have a function and I do the vertical line, it crosses twice, then it's not a function. Okay? So what if we had a function that would undo another function? Kind of wild, right? What would you call it? So right now, I want you to think, just if you were creating something new. So let's say you had something that's concrete already in place, and you develop something new that will kind of undo what's already done, kind of reverse the process. What would you call it? Okay, so right now I want you to write down ideas right here. What would you call it? There's no wrong answer, only a no answer is the wrong answer. So I want you to think of a word or a phrase that will symbolize or will state undo? Or what would you call a function that would undo another one? Okay, I'll give you guys some time to think, pause the video, and think about it and write it in your journal. Okay, so page 2. Page 2 has quite a bit of notes. I would have already put up the file for you guys so you guys could have pre-written all these notes prior to watching the videos. So always remember that. You're going to write all the notes that I post, and then you're going to watch the videos and you're going to fill in the notes, okay? So I'm big on color coding, and right now I haven't really told you what to color code, but right on page 1 or the table of contents. But on this page, I do want this right here, this table number 1. I do want it in purple, and I do want table number 2 in green, the axis in red, the y-axis in blue, and then of course these points are in purple. Okay, so I want you guys to kind of just look at this, these two graphs. So table 1 is right here in purple. Table 2 is right here also already graphed out. And I want you to kind of answer these questions. So look at the tables and what do you observe? How are these two graphs related? And if there's something occurring, what is occurring? Okay, so hopefully you guys have had some time to kind of answer these questions. If not, pause this video right now and go ahead and answer them. Again, there's no wrong answer unless it's a no answer. The only way you can get this wrong is if you leave it blank. Okay, so now I'm going to let you guys pause the video and then you can come back. Ready, set, go. Press pause. Okay, so we're back. So what do you observe? Now, what I'm going to do first is I'm going to observe the tables. So what do I notice here and here? So I notice something. I notice this left column becomes this right column, and this right column becomes table 2's left column. So in essence, I see, well, you know what? I'm going to use a different color. I see that the X and Y's switch positions. So I see the X and Y switch positions. So I see that these are kind of like flip-flopping to form this table over here. So when I look at the graphs, well, then they kind of look like a mirror. It's kind of like this person right here, or this graph right here, is taking a selfie, and this is the selfie, right? Kind of flips everything backwards. It's kind of like a mirror, right? So that person's taking a selfie picture, and this is the actual picture. This is what you see, what you mirror, right? So when that happens, something nice and mathematically is happening on the graph. And what's happening, guys and girls, is that there is, let me choose a different color. Let me see. Let's go with orange. Okay, orange. Yeah. What's happening is that there is a line that goes through both these graphs at y equals x. And what happens is this line is acting as the mirror. It's acting as that, I guess, that camera phone that lets you take that selfie. It's that mirror. So this y equal x kind of mirrors this top part, converts it this way, and vice versa. Okay, so this is going to lead us into something else. Okay, so this is what we call an inverse. So we're kind of reversing the position. We're reversing the x and y positions, and we'll discuss that a little bit more Let me just lift up the notes, okay? So, did that. So an inverse function is a function that reverses another function. I kind of like to think of it as, if you guys have ever seen the movie The Matrix, there's the hero, Neo, and then there's the villain, Mr. Smith, or Agent Smith. And what happens is, I don't want to spoil it for you guys, but I'm going to have to, is that Neo is the answer to Mr. Smith, and Mr. Smith is the answer to Neo. Kind of like, I think of it like yin and yang. So separate, they're two different entities, but together they're one, and that's key. So whenever you have a function and you have its inverse, so a function together with its inverse will equal to 1. Kind of like the yin and the yang. That's supposed to be the dark part of the yin, and well, you guys get the point. Okay, so let's say we had two functions. We had f and g. F would be our original right here, our given, and g would be our inverse. And to get our g, all we do is we reverse the x and the y's. Okay, so we denote that. We denote the little inverse, but not a little inverse. We denote the inverse with a little -1 script. Okay, so that's key. So whenever you see f of -1 like that, that says that that's a function's inverse. Okay, so what I want you guys to do right now is I want you to think. So if to find an inverse, all we have to do is switch the x and y positions. What happens when we're given an actual function? What do we do then? Pause the video, think about it. What do you think we do now when we're not given points? We're now given an equation. What do you think we do? Pause the video, think about it, write down your response. Again, there's no wrong answer unless it's a no answer. Ready, set, go. And we're back. So, what do we do in this situation? Well, we just continue to do what we were doing. We switch the x and the y. Okay? In this case, we know f of x can be denoted as y. So what I'm going to do is I'm going to switch them. X and y. And what I want to do is solve for y. So how do I get rid of a times 5? Well, that's just divide by 5. So we have x divided by 5 is y. And that would be my inverse. But what do we say about writing inverse? How do we denote it? We denote it as saying f to the -1. And then we get the x over 5. So this is the inverse to this. So what about this one? What do we do? Same concept. We switch the x and the y and solve for y. So how do I get rid of a -2? A +2, -2. How do I get rid of a ×2? Divide by 2. And again, how do we denote the inverse? F of -1 equals to x -2 over 2. Okay, so now we have some practice problems to work on. So there's 8 problems, and I'm not going to do all of them. I'm going to do maybe 3, okay? So I will start with, Actually, I'm going to use, I'll use black. I'm going to start with number 3, actually. Okay, so what do? I already know f of x is y, so I just switch my x and my y. How do I get rid of a minus 2? Plus 2. Now, how do I get rid of a cube? A cubic power. I have to take the cubic root to both sides. So now I have y and then x plus 2 cubic root. However, what do we say about writing inverse? Do we use y? No, we don't. We use f of -1 x. And I'm asking you guys to, whoops, let's use this one. I'm asking you guys to use red to box in your inverse. Okay. So now I'll do another example. I'll do number 5. So what do? I switch my x and y. I already know this is y, and I see my x there, so I'm just going to go bap, 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 bap. Okay. So this is a positive 2, so I'm going to minus 2. That's a plus sign, guys. So x minus 2 equals the square root of y minus 5. Well, now I have a square root. How do I get rid of a square root? I take it to the power of 2. So I take all of this to the power of 2. How do I get rid of a minus 5? I add 5. So I have x minus 2, all of that squared, plus 5. And that equals to y, but I'm not going to write y. What am I going to write? Because it's my inverse. F to -1 x. And then I'm going to box it in red. So now, what about these bottom ones? Man, these fractions. Hardly anybody likes dealing with fractions, but we're going to deal with them today. Same process. Let's do it. Oops. Switch the x and the y. I first minus 4. How do I get rid of a divide by 3? Multiply by 3. So now we have, I'm actually going to distribute this. So I'm going to have 3x minus 12 and y minus 2. How do I get rid of a minus 2? I add 2. So now I have, bring this up a little bit, 3x minus 10. Do I write y? No, I do not. I write f up to -1 x. Remember, that's my inverse, so I have to denote it that way. Whoops, I forgot my parentheses. Okay, so what I want you guys to do right now is I want you to practice. Practice 1, 2, 4, 6, and 7. Okay, so pause the video, try them out. I know my handwriting is not great, but I'm trying my best, guys. Okay, so try them out, press pause, follow the steps. If you have any issues or problems, we could go over some of these the next class meeting. Okay, so I just realized something. I realized that when I was writing up these notes, I put that my exclusion right here. So right here, I cannot have the denominator ever equal to 0. So when I'm doing this type of inverse problem, or any type of problem, actually any type of function, I have to note that x cannot equal to 5. So in this case, x cannot equal to 1. Here, x cannot equal to 0. here, x cannot equal to 4. Oops, cannot equal to 4. Okay, so make sure you fill those in. So now these are now where inverse gets nice and mathematically, right? This is where we use our mathematical skills and our algebra 1 skills and we put them to the test. Okay, and we do that because we notice something. We notice that there's an x on the bottom and there's an x on the top. We have an x in the denominator and we have 1 in the numerator, which is going to make things a little bit not difficult, but it's going to require more steps. It's never more difficult. It's never difficult. It's just a step up in level as far as more steps. Okay. So again, we switch our x and our y. So we're going to have y here. Whoops. X here. And we're going to have 2y over y minus 5. I don't really have to worry about this right now, as that's just more of just being thorough, right? So how do I get rid of this? How do we get rid of a divide by y minus 5? Well, we multiply by y minus 5. Multiply by y minus 5. And I'm going to distribute that. So I'm going to have xy minus 5x equals 2y. But oh my goodness, now I have 2 y's and I have 1 y on the left and 1 y on the right. So what should I do? Well, you know what? I'm still trying to solve for y. So let's bring all the y's on one side. Let's subtract xy. Subtract xy. So now I have negative 5x equals to 2y minus xy. But hold the phone. If two things have something in common, can't I just factor that out? I could factor out a y. Well, if I factor out a y, and this is just times, I now can get rid of this by dividing. So I have negative 5x over 2 minus x, and that equals to y. But we're not looking for y, right? Well, we are looking for y, but we don't denote it as y because we're actually finding the inverse. So we're going to write f to the negative x. And what do? We box it in red. So we know that this is the inverse to this. But hold the phone. Notice this has a denominator. So we have to include something like this. So I'm going to just include it in right here. X cannot be 2. Because if it's 2, then it becomes 0, and we cannot have that. It is not a function, okay? It just doesn't work. So I'm going to do one more, okay? I'm going to do number 2, and I'll let you guys do 3 and 4 on your own. And what I'll do is I'll post my work, or we could go over it in class on the next class meeting, okay, guys? This way, you guys get some work. And if you guys could get these 4 problems, you should have no problem getting the homework. I promise you. Okay. Right here, we switch the x and the y. How do I get rid of a divide by y minus 1? Multiply by y minus 1 to both sides. I distribute this. Bad. So I have xy minus 1x equals y. I bring this xy back over here. So I have negative 1x equals y minus xy. I factor out the y's, leaving 1 minus x. Now I divide. So I have negative 1x over 1 minus x equals to the inverse. And again, x cannot be 1. We have to remember we have to put that in there, because if not, then somebody will call us out Be like, hey man, what if I put 1 there? That's not the inverse. Throws everything off, right? So we have to exclude that number. Okay. So guys, try them out. Okay, try them out. Oh, you know what? How about I just do them? Let's just do them together. Okay, I'm gonna pick this up a little bit. Let's just do them. Okay. Well, if you want, you know what? How about you do this? Pause it. Pause the video. Pause it. Try them out, and then once you're done with 3 and 4, see if you got the same answer as me. Okay. So I'll let you do that. Pause. Okay. Now let's check our answer. Let's check our work. Okay. Multiply y to both sides. Well, in this case, I know earlier we were bringing the xy this way, but in this case, it would actually be easier to bring the 2y this way. So sometimes you could go either way, right? And you just got to see it mathematically. So right here, and now we factor out a y, and now we divide. And remember, we don't leave it as y, we put f to negative 1x. And then we always have to denote that x cannot equal to 2. If you guys could hear my son taking a shower right now. Sorry about that. Okay. Next one. Last problem. Switch x and y. This is a 4 and this is a y, guys. I know my handwriting's horrible. It's kind of hard to do it on a computer screen, guys. I'm telling you. I'm better on a chalkboard, on a whiteboard. Okay, so these cancel. Bat. So now we have 4x minus xy equals y. We add xy to both sides. And we have 4x equals to y plus xy. And then in this case, we always factor out a y. 1 plus x. Now we divide 4x over 1 plus x. And remember, we're not going to write y no more. We're going to write f of negative 1, which stands for inverse. And then we have to say x cannot equal to 1. And that's my inverse, guys. That's how we do inverses. So pretty much all you have to do is switch the x and y positions, solve for y. Once you do that, you change the y to f of negative 1. And that's it. You're golden. So that's inverse functions for you guys. You guys will probably have some homework on this. But if you could understand these 4 problems, all the other problems will be a piece of cake, I promise you. All right? Thank you.